Eric Burgess here, and we've been given the following equation. It's got three variables, a, x, and b, and it also has some numbers, and they want us to solve for x. So the name of the game here is we got to get all the x's on one side and all the other stuff to the other side. And once we have the x's all together, we're going to try and separate them all out or combine them if possible. So let's get to that step, and then we'll see what to do from there. So we've already got an x on this side, and I kind of like x's on this side. So I'm going to move this term that also has an x over to this side. So to do that, I'm going to do the opposite of it. So that would require me putting a negative bx on both sides. So we put a negative bx plus 4a minus ax equals 3b plus bx minus bx. So we're saying this is the same, right? I put the same thing on both sides, so they're still equal. So it's an equivalent statement. And bx minus bx goes to 0. And so those conveniently just go away, or not conveniently, we picked it that way. And so we are left with minus bx plus 4a minus ax is equal to 3b. All right, so from here, we want to get rid of this 4a because it doesn't have an x, and it's going to be a little more tricky to work with it on this side. So we're going to do the opposite of that. So we're going to do minus bx plus 4a minus 4a minus ax is equal to 3b. And then we're going to do the minus 4a because if you do it to one side, you got to do it to the other so that you keep the equality happy. So this goes to 0 because 4a minus 4a is 0. And we're left with minus bx minus ax is equal to 3b minus 4a. So from here, we've got all the x's on one side, or at least all the terms with it. So we can actually factor the x out. It's like we're dividing by x. So if I went like this and divided each term by x, and then I multiplied by x, these x's here, when I distribute the x in, it would cancel with this x and with this x. And so it's like I'm multiplying by, let me write it another way. It's like I'm multiplying by x over x, right? This is really just 1, right? Anything divided by itself. And because it's just 1, when I multiply this in, it's completely valid. It's going to stay the same because anything times 1 is itself. And so let's go ahead and look at it from this perspective. So this would be like x times negative bx, and I'm going to only bring in the bottom x. So when I multiply the bottom x in, and remember fractions, they multiply straight across. So these are really like they're over 1. And so the bottom x goes in. These turn to 1s when they simplify. And we're left with x times negative b minus a is equal to 3b minus 4a. And so now if I were doing this just at my regular pace, what I would look at this and immediately go, I would look at this statement, minus bx minus ax, and I would immediately just take the x out, minus b minus a. Like that would be my next line. No further thinking. You get good at spotting it after you sort of see it. You're just like, oh, okay, I could take the x away since they both have an x. But this is the justification for why you can do that. So, okay, now that we're here, this x is times this whole thing. So what we're going to do is we're just going to divide by that whole thing to both sides. So we're going to take minus b minus a minus b minus a. We're just going to divide it out. And we get that x is 3. Let me write it better. 3b minus 4a over negative b minus a. And this would be our solution. So that's how you would do a problem like this. This one involves a bit of factoring, which is kind of cool. And let me just zoom out so you can see everything. If you have any questions about this, let me know. Subscribe. If you're a Citrus College student, definitely feel free to stop by online tutoring. We're there to help you out. And we'll catch you in the next problem.